Hello everyone, welcome to solve this nice math Olympiad algebra problem. And here we have b plus square root of b is equals to 56, and we solve this problem for all the values of b. So here first I can just find the interval in which the solution of this problem is lies. So for this we need little bit simplification. We move b to the right hand side and it will becomes square root of b is equals to 56 minus b. And now first we find the interval in which the solution of this equation is lies. So for this you know that the square root sign is always gives us the positive value. It means that here our b should must be greater than or equals to 0. And similarly the square root become positive value gives us the positive value, also b is positive, then this means that 56 minus b is also greater than or equals to 0. From here we move this minus b to the right hand side and we obtain 56 greater than or equals to b. And when we combine these two values, we obtain here 0 is less than equals to b is less than equals to 56. So this means that or this implies that our b should must be belongs to this close interval 0 to 56. This means that the solution of the above equation is lies in this interval. Okay, here we move towards to find the required solution of the given equation. For this we copy down given question statement. Here it is b plus square root of b is equals to 56, and here we take a little bit substitutions here, and now here we substitute y is equals to square root of b. We substitute this value equals to y, and when we apply squaring on both of the sides we obtain y square equals to b. It means that we substitute this b equals to y square and the square root of b is equals to y. So after substituting both of these two values to the above equation, it will be written as y square plus this is y is equals to 56. And further in the next step we move this 56 from right hand side to the left hand side and it will becomes y square plus y minus 56, and this whole equation is equals to 0. And in the next step we need to take you see here this equation will becomes quadratic equation, and we know that there are three methods to solve the quadratic equation. The first method is factorization method, second one is completing square method, and third one is by applying the quadratic formula. So here we make the factorization technique to find the factors of this equation. So here we need to break its middle term. So for middle term you see here the coefficient of this term is 1, and when we multiply 1 with minus 56 it will becomes here minus 56, and here you see that the coefficient of this term is 1, so this is here we write plus 1. So here we need any two numbers whose product becomes minus 56 and whose sum becomes here plus 1. So we need to find that numbers. So here we have some possibilities. The possibilities are 8 multiplied by minus 7 is equals to minus 56. So we find two numbers 8 and minus 7 whose product becomes minus 56. And now we need to check the sum, is the sum of these two numbers is plus 1 or not. So you see here 8 minus 7 is equals to plus 1. So it means that these are the two numbers whose product becomes minus 56 and whose sum becomes plus 1. So it means that these are the two suitable numbers. Now we break our middle term according to these numbers, and it will be written as y square plus 8y minus 7y minus 56, and this whole equation is equals to 0. And now here in the next step we need to take common y from first two terms, and when we take common y we get the remaining values are y plus 8, and here we take common minus 7 and we get the remaining values are y plus 8, and this whole equation is equals to 0. And now in the next step we need to take common y plus 8 from here, and when we take common y plus 8 we get the remaining values are y minus 7, and this whole equation is equals to 0. So further we divide this equation into the two cases. The first case is we write y plus 8 equals to 0, and the second case is we write y minus 7 is equals to 0. From here we get the value of y equals to minus 8, and from here we get the value of y is equals to plus 7. So now we find the values of y, but now here we need to move backward and we substitute the value of y is equal to square root of b on both of these two cases, and we get the values of b, because here in this question we need to find the values of b. So we back substitute the value of y, and it is square root of b equals to minus 8. In this case again we have square root of b is equals to 7. And now for the values of b, we need to take squaring on both of the sides on this case and this case as well. These two and square root are gone, and we get here b is equals to, this is minus 8 square, and minus 8 square becomes 64. And similarly from here, these two and square root are gone, and we get here b is equals to, this is 7 square. 7 square becomes here 49. So this is the second value of b. And now you see here we obtain two values of b. One is 64 and second value is 49. So now if we move backward and in the start of the problem find the interval of solution. So this is the interval in which our solution is lies. So we first copy down this interval here. So 0 is less or equals to b is less or equals to 56. So our solution is lies in this interval. So you clearly see here 64 is not lies in this interval because it is lies outside the interval. Here the interval end with 56, but 64 is lies outside the interval. This means that b equals to 64 be the extraneous root of the given equation. Okay, further if you verify both of these two values, when you substitute both of these two values to the given question statement, the value b equals to 64 is not satisfied our given question statement. So this is the extraneous rule, but b equals to 49 is lies in this interval. So finally we conclude about that the solution set of this problem is b equals to 49. So this is our final answer, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.